Hey team, so this lesson we're continuing on with trigonometry and we're finishing it off with bearing problems. So a plane leaves an airport and flies 600 kilometers on a bearing of 145 degrees. How far south of the airport is the plane to the nearest kilometer? So the hardest thing is going to be drawing pictures for these problems, which is what I know you guys are going to struggle with. So I'm going to show you how to do it. Break the question down. It says a plane leaves an airport. So if the plane is going from the airport, let's start off with the airport. It leaves the airport and flies 600 kilometers on a bearing of 145 degrees. So if we're leaving from the airport and we're going on a bearing of 145 degrees, then that is going to be somewhere down here, right? Because if this is our north, and then here we've got east, south, the plane is leaving this airport and it's flying on a bearing of 145. So what we can do is assume, well, we know 145 degrees falls between south and east, right? Because that's 90 and that's 180. So it's going to be roughly in between there somewhere. So let's just draw a line because that tells us that's this bearing of 145 degrees. Doesn't have to be exact, just roughly. And if it's traveling for 600 kilometers, that means it's going near 600 kilometers, which means this is also a length of 600 kilometers. And this is where our plane now ends up. So here's our plane. And that's that part. And then it says, how far south of the airport is the plane to the nearest kilometer? So how far south means that if this is our airport and this is our plane, it is south, right? Directly, like, it's not directly underneath, but how far south means what is that distance there, right? It's the same distance as over here. So from the airport, it is like the aeroplane is obviously in a southeast direction. But if we're talking about how far just south means how far below is it? And that is this distance, that X distance, or this one, right? In saying that, to work out how far south it is, we're going to want to know what this length is going to be. But because we're talking about north, east, south, and west, each quadrant is 90 degrees, which means that that actually forms a 90-degree triangle. Because imagine that that's that north, that line continues down, and then because it's out that way, we can form a 90-degree triangle. Now what we can do is find this length by using our trig. But first of all, we're going to need an angle. We can find this angle in here because that whole angle is 180 degrees. And what we can do is just go, that angle right there is 180 minus 145, which gives us 35 degrees. And now we've formed a triangle. Where that's 600, we've got X, and that's 35 degrees. Using our trig functions, remember it's SO, CA, TOA. We've got the hypotenuse, the adjacent, and obviously this is our angle in here. So we're going to have to use cos. So cos of 35 degrees, remember it's cos theta equals adjacent over the hypotenuse, where we've got cos of 35 degrees is equal to our adjacent, which is X, over 600. Remember, we times everything by 600. And we get X is equal to cos 35 degrees times 600. Put that into your calculator, and you roughly get 491.4912, and we want it to the nearest kilometer. So that's approximately 491 kilometers, which makes sense. If that distance is 600, that's going to be, we need this distance to be shorter than 600 because 600 is the hypotenuse, which means it's the longest. So then, therefore, it's that many kilometers south of the airport. Okay, question 2. From camp, Andy walks due north for 8 kilometers and then 6 kilometers due west to a lake. How far is Andy from the camp? When it says due north, what that means is Andy walks like pretty much directly, well, bang on, directly in north direction. So not on any kind of bearing, he walks dead straight north. And then what happens, he turns and walks due west, which means he walks north, right? He walks in this, let's say here, he walks in this north direction, and then he turns and walks due west, which means he walks directly west. So drawing that as a picture, let's say this is our guy. This is Big Dog Andy. He walks due north for 8 kilometers. So he walks north. I'm going to move this down. North for 8 kilometers, which means, wow, directly up for 8 Ks, because that's our north. And then from this point, he walks 6 kilometers directly west to a lake. So that means he goes literally directly in that west direction, because remember, we've got north, east, south, and west. Okay. All right, so he walks 6 kilometers that way. And this is where he ends up. And he ends up at a lake. All right, as you can see here, we have begun to form another triangle. Part A says, how far is Andy from the camp? So, I probably shouldn't label that Andy. We'll call this is the camp. And this is the path that Andy walks. So how far away is he from the camp? Well, that means we're going to have to want to find this distance here. That will give us the distance from camp. And again, this is a right-angled triangle because we're talking about north and then directly west means it forms that 90 degrees. We can use Pythagoras' theorem now. So remember, using Pythag, we've got c squared equals a squared plus b squared, where our c is our hypotenuse, so x squared equals just the other two sides, so 6 squared plus 8 squared, and that equals 100. But we don't want x, we want x squared. So we have to take the square root of both sides, and we get the square root of 100. Remember, it's plus or minus, but because we're talking about a distance, it's only the plus version, so it's 10. So therefore, Andy is 10 kilometers from camp. That's for part A. Part B is, what is the bearing of the camp from the lake? So remember, we're talking about from, that's where we're going to draw our compass rose. So because we're going from the lake, here's our lake, we're going to draw a compass rose bang on our lake. Beep, beep. Okay. A bit thicker. And we want to know what is the bearing of the camp from the lake. So we want this angle in there. That'll give us the bearing. Well, we already know that that's 90 degrees. If we can work out this angle in that corner, we'll be able to find out what the whole angle is. So let's call this angle in here theta. Just drawing this triangle out, we can work out what theta is by using our trig functions again. So remember, if this is our triangle, if this is our angle, we've got our adjacent and our opposite. So we're going to use tan. So if we use, I'll just move this down here. This is for part B. if we set it up with tan theta is equal to, remember it's opposite over adjacent, so tan theta is equal to 8 over 6. And because we want to find tan, remember we have to use tan inverse. So you have to press shift on your calculator. So tan inverse of 8 over 6. And that will give you 53 degrees, 8 minutes, roughly, approximately. I didn't tell you the approximation, but that's okay. Yeah, so that's that angle, right? But because we want the whole thing, you just add it to 90 degrees. So we got 53 degrees and 8 minutes plus 90 degrees is going to be approximately 140 degrees and 8 minutes. Okay, so therefore the bearing of Camp from the Lake is this. My notes are all over the place and I apologize for that. That's there. Okay, I hope you can make sense of that. You will probably definitely have to have watched the video to get this. Good luck.